Hello and welcome to the first part of the series. This is more of a physics tutorial. Okay, so first let us start with the first topic that you may encounter when you are about to study physics. Let's start with units. Let me write here units. Okay, so units is telling us more on dimensions. Okay, we can express a unit in SI or in imperial system. Depends on the nation where you are living. Okay, so how essential these units are for us. Suppose you were asked how old are you, and you're about to answer, let's say 16, 17, 18, 19, 20. Okay, and what are those numbers stands for? Are those numbers let's say 16 months, 16 weeks? Okay, so we do not know. No? I know na kapag meron kakaharap na, let's say, kausap mo, no, and he looks like a teenager, then definitely that must be years, no? But when we deal more in complex scenarios, okay, the case will be very different. Okay, so let's start with some units. In SI, we can measure dimensions like time. We can express the time in terms of seconds. Okay, so the symbol would be simply S. Okay, we can also measure the dimension of length. That would be in meters. Symbol would be M. We can have the dimension of mass, a quantity of mass that we can measure in terms of kilograms. That would be kg. Okay, we can also have some derived quantities. Okay, suppose we have speed or velocity that we can express in meters per second. That would be m over s. We can have acceleration. That would be meters per second square. That would be m over s square. Or we can have force, if you want so. That would be in newtons. Newton symbol is just simply capital N, and in terms of fundamental quantities, we can write it down as kg times m over s square. That would be mass times the acceleration. Okay, so we can also write Newton in this way. Alright, some equations might be confusing for us, that probably you're about to ask yourself for those equations, that can they really exist? Okay, so for us to know that if the equation truly exists, we can analyze the dimension present on that particular set of equations, for example. So we have here dimensional analysis. Okay, we're going to analyze dimensions. Okay, we're going to compare dimensions on this side of the equation and on this side of the equation. Let's have the most basic kinematic equation that you're about to encounter. Okay, let's have delta x over delta t. That will give us speed. Let's just simply write speed as v. Okay, I can write this one as x minus x initial over t minus t initial. Okay, the dimensions for v, I know that v is measured in meters per second, as I've written here before, and so the dimensions involved are length per unit time. Okay, so here the dimension of x, I know that is in length, so that would be L. For time, that would be t. Okay, and so you will see that what will be the dimensions for v, same as the dimension on the other side. X over t, that would be dimension of length over time. Okay, and so this equation really exists. Okay, I know that it is already proven and tested, so there's nothing more we can do about it. Let's try another one. For a uniformly accelerated motion, let's have x will work as 1/2 v times t. Okay, this equation is very linear for us. Okay, you can add some extension. Let's say that you have here, sorry, this is x initial. Okay, you can write this way. Okay, so let's analyze what would be the dimensions present here. I know that the dimension on this side must be the dimension of length, so the dimension of length must be present on the other side. So let us analyze. Having constant numbers present in the equation, okay, like this one, will deal nothing with the dimensions of these physical quantities unless the number is an exponent. If an exponent is existing right within one of these physical quantities, then it can alter what will be the dimension for that quantity. Okay, so you have to remember that. But this equation, let's say this is 1/2, this is 2, this is some integer, negative or minus integer. It has nothing to do with the quantities, or I mean the physical quantities. Okay, V is expressed in meters per second, that would be L over T, times time, plus L. So I can cancel this one, and what L plus L will give us simply L. Dimension of length plus dimension of length will give us dimension of length. So this equation exists. Okay, let's have another equation, another kinematic equation. Let me write it here below. Okay, let's have another kinematic equation. That would be 2ax is equals to v square minus v initial square. Okay, so I can rewrite this equation as 2x is equals to v square minus v initial square over a. So let us analyze the dimensions. I have here dimension of length on this side. Let's be equals to the dimension of the other side. So let's have v, that would be L over T. You can square it, minus L over T. Square it later. Then I have here A, that is meters per second square. That would be length over T square. Let me move here. So I can play with this equation. So that will give us L. This becomes L square over T square divided by L over T square. So in dividing fractions, you will get these. You are about to get these. It's reciprocal. Then you can proceed to multiplication. Comes T square over L minus same thing, L square over T square times the inverse of this one, becomes T square over L. So simplifying this one, we can cancel these T's and L for an L square. So L minus L will give us L. So this equation do exist. Okay. For example, you are given an equation, let's say that is the universal law of gravitation. That would be Gmm over r square. Okay, this G is a constant. Suppose that, let's say, you know what is the constant is, but the question is, what would be the unit for that constant? I know that this is newtons, this is in meters square, this is in kilogram. They are both in kilograms. The only difference that one is larger than the other. But anyway, that will give you kilogram times kilogram, that is kilogram square. So the question is, what would be the unit for this capital